March 4th, 2017, I have this book, Rocks and Gems. Very cool book. On page 58 on rock salt. Rock salt. I'll read a little bit of this out to you guys. Occurring in beds that range from a yard or so to more than 1,000 feet in thickness, rock salt is the massive rock form of the mineral halite. It's familiar as common table salt. It's, chlorine and sodium. It forms as a result of the evaporation of saline water in particularly enclosed basins, and is commonly interlayered with beds of limestone, dolomite, shale, and other evaporates such as gypsum and anhydrite. It is found in all continents, with particularly large deposits in southeastern Russia, France, India, Canada, and the western and central U.S. Think about a deposit of an evaporate 300 meters thick or 1,000 feet thick. How much ocean water would it take to make something that deep? So say you have a large layer of saline water, basically, and you have a depression in the land. So what happens is you'll have this large amount of saline water evaporating, and it will leave all the salt collected in like a dome configuration. I don't know if that's correct, but the dome would be kind of like this versus like this if it's coming upwards. I'm just thinking about this because in the theory I'm developing, you have Earth having been a ocean world. So you had very, 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 very deep oceans. And this is evidence of there being very, very deep oceans, because why should there ever be evaporates present? Well, it's because that's what was there. That's what allowed for that salt to collect together on the surface. As well, it's a good way to mine the salt by just taking ocean water and placing it into large areas where, it's on the upper left-hand side, large areas where the water can evaporate and leave the salt remains left over. So think of that happening in very, very large scales on the Earth, where you have deep oceans and they just evaporate, and then it leaves whatever materials left over. That being said, halides. Halides are a type of mineral. I'll go ahead and read this out, page 170. Halides are minerals consisting of metals combined with one of the common halogen elements, fluorine, chlorine, bromine, or iodine. Compositionally and structurally, there are three broad categories of halide minerals: the simple halides, the halide complexes, the hydroxy halides. Oh, that's it. A simple halide is formed when a metal combines with one of the halogens. Halides such as sodium and chlorine, and fluorite, calcium and fluorine, are examples. Many of the simple halides are soluble in water. And here's a fluorite crystal structure. You have your fluorine ions in green and your calcium ions in red. That's really cool. If you go to the Smithsonian, they have fluorine crystals, these giant fluorine crystals. They're purple, they're gorgeous. I'm going to steal them. No, not really. I'm not going to steal anything from the Smithsonian. I'd probably go to jail for a long time for that. But anyways, you have halides, and this is where my mind is when it comes to ocean worlds. You have all the water being evaporated away, and whatever is left over, it condenses as an evaporate and forms these large deposits of salt and gypsum and other types of minerals too. Alright, I guess I just want to let y'all know where my mind is. If you guys want to read up more about these crystals and how they form, go right on ahead. Later, y'all.